This is the 2016 Rockwell Collins Capstone project. My name is Justin Maltz, and I am joined by Gabriela Beardon, Nicole Burkholz, and Travis Christensen. In this project, we are tasked with creating a core C++ library to convert raw networking log data into a more human-readable format, and in a format that could be possibly used in other applications used by Rockwell. We were also tasked with creating a front-end application to be able to display this data and visualize this data and look for trends in the data. Now to begin, the data is going to be in a raw format, so what we had to do was utilize Google's protobuf API. Now in Google's protobuf API, you define what's called a message, where you pipe messages through the protobuf API to be able to read this raw data format. So Rockwell Collins supplied us with a proto file, which is basically a definition of the messages that will be parsed out of the raw networking log data. So if you see here, we have a base message class, which includes the 3 types of statistics that we're mainly going to look for, or message types that we're mainly going to look for, them being IP table stats, switch stats, or Ethernet stats right here. Now, to kind of begin here, we have a file that's in a raw data format, as you can see right here. There's nothing that you can really do with this file. There's no information that you can read out of this file. It's in raw data format. So what we do is we created a core C++ library that's going to be utilized by a conversion application to convert it into JSON data format. So it's just app.exe, and then we supply the actual file name here, which is com IP table stats .0.row, and we'll pipe it out to a file. Let's just call it test.json. We'll let that run. And you can see here we have a brand new converted JSON file. And if we open this up, we can see all of the data that's been newly converted. Now we are going to demo our GUI application. Our GUI application was made with AngularJS, with our charting API being HighCharts. Very basic. We have an ability to upload log files from the home screen, as well as upload files from the actual nav bar. We have options that we can choose to customize the graphs a little bit, such as the interval of the update messages, or being able to display the delta on the packet charts, which we'll see in a second. So let's first upload files. Let's start with the file that we just converted. So we'll upload that. And as you can see here, these are the types of charts that we display for IP tables. We have input bytes, input packets, input bandwidth, and then the same will be repeated for output as well as forward. We can also zoom into the graph by clicking and dragging, and that gives us a closer look into the data. So with so many data points, things get a little convoluted, and this just allows Rockwell to better see the data at specific points. In the options, we discuss the abilities to change both the interval and the packet delta. So right now, the interval is defaulted to every 2 minutes, and you'll see that on the x-axis. We have about 720 data points, so we get that over the course of about 1,440 minutes, as you can see there on the x-axis. So if Rockwell had a file that updated every 3 minutes as opposed to every 2 minutes, they would want to be able to change that. So if we change that to 3 minutes, and we update our settings, the graph should redraw based on that new interval. As you can see down here on the x-axis, now it goes up to over 2,100 minutes based on the amount of data that we have. Now, we also have the ability to update the packet delta. The packet delta is the difference between the current packets received and the last packets received. So if we click this here, we update our settings, any packet chart should now display as a packet delta. In a switch stat file, we have the errors, as you can see here. On the error graph, we look for every single error type per index, and if an error is found, it will be displayed on this bar graph here. If you want to take a closer look at the errors, figure out where these errors actually occurred, you can click on the bar graph, and it will show you how many errors occurred and where they occurred. So now we'll take a look at Ethernet stats on the GUI. Ethernet stats are going to be a lot like switch stats. We have the error graph just like on the switch stats with the drill down, so we can see where the errors actually occurred. You can see here, series 10 had 10 errors occurring at the very tail end of the file. We'll also have the status graph, much like the switch status graph, a 1 being that the connection is online, and a 0 being that it's offline. And then we also have the packets received and packets transmitted, etc., like we would see in other graphs.